Hi everyone, in this video I'm going to go over how to do average atomic mass calculations. Sometimes this is called weighted atomic mass or just atomic mass. So what is atomic mass? When you look at your periodic table, and sorry it's laminated so that's blurry, it is the mass that's listed. So boron's atomic mass is 10.812. And what is that? It is a weighted average of all of the isotopes of boron. And so what does a weighted average mean? A weighted average is like your grades. Your grades, your tests count more for your grade than your homework does. That's a weighted average. And so when it comes to these atomic masses, the isotope that is the most common counts more towards that average mass. It's like a test versus isotopes that aren't really common. They're like your homework. They don't count as much for calculating the atomic mass of that element because they don't make up much of the element. So you do need to know the formula for atomic mass. And again, it could be called atomic mass, average atomic mass, weighted atomic mass. But to calculate it, you're going to take the mass of the isotope and multiply it by its percent abundance, which means how common it is. And usually there's more than one isotope, so you would add that with mass of the next isotope times that one's percent abundance, and so forth and so forth. If there were 3 isotopes, you would do a third plus mass of the next isotope times its percent, so forth and so forth. That's how you calculate atomic mass. And so today I'm going to work through a few problems just to practice this with you. So we're going to look at this number 1. Calculate the average atomic mass of sulfur if 95% of sulfur has a mass of 31.72 AMU, if 0.76% has a mass of 32.971, and if 4.22% have a mass of 33.967 AMU. So first thing you notice when I read this problem, I underlined my numbers. And I made sure that I underlined them different. Maybe you could use a different highlighter to indicate the 95% goes with that. The 0.76% goes with that. 4.22% goes with that one. That way I don't mess it up. So I have the masses of my isotopes, and I was given their percents. And so to calculate it, it's mass times the percent. However, whenever you have a percent, you don't multiply by the actual percentage. So I'm not going to take 31.972 times 95 because it is a percent. The word percent means out of 100. And so you have to change all of your percents to decimals. And how you do that is you take the percent and you divide it by 100. And that's what you're going to multiply by. So this 95% in your calculator, 95 divided by 100, and you'll get 0.95. Let's write that right there. That's what you'll multiply this number by. 0.76%. Again, you need to divide it by 100 because it's a percent. It's out of 100, and you get that would equal 0.0076. This one is 4.22%, so divide that one by 100, and it is 0.0422. Now that we've converted all of our percents to their correct decimal, we're ready to type this in. So I want to find atomic mass. That will equal mass of the isotope. So 31.972 times its percent. And again, I have to use the decimal, not 95. So 0.95 plus mass of my next isotope, 32.971 times its percent in a decimal, so 0.0076 plus mass of my next one, 33.967 times its percent, 0.0422. And type that all in your calculator. Make sure, just how I wrote it in parentheses, you use parentheses when you type it in. That way you don't do your order of operations wrong and nothing gets done funky. Percents just make sure everything works out perfect. And you should get the average atomic mass equals, or the atomic mass equals 32 it's 0577, so 06. And the unit for atomic mass is AMU, atomic mass unit. And that would be how you solve this problem. Now, every time you do a math calculation, I call it do a common sense check. The average atomic mass is 32. Most of the isotopes have a mass of 31.9, and some have a little bit more. So having this grade of, or this average of 32 makes sense. Your atomic mass should be closest to the mass of your most common isotope, because it's a weighted average. Just like your average in a class is going to be closest to your test grade, this should be closest to the isotope that has the most abundancy, or that's the most common. So for example, let's go back to the periodic table in boron. Boron there is a boron with a mass of 10, and there is boron 11. When I look at that average atomic mass, it is 10.812. That is closer to 11 than 10. What does that mean? That means boron 11 is more abundant than boron 10. There's more boron 11. It has a higher percentage than boron 10. Carbon. There's carbon 12, carbon 13, carbon 14. But because carbon's average mass is 12.011, that tells me carbon 12 is the most common, because again, these atomic masses should be closest to the isotope that's the most common. Let's do another calculation. We're going to jump to one that is a little bit different. This one, number 10, if you want to pause so you can read it. So while this one is different than the one we just solved for, one, it's a fake element. Two, I gave you the average atomic mass. It is that. I told you it's got 3 isotopes. Tigerium 125 is that percent abundant with that mass. The other one, Tigerium 126, is 4.52 abundant with that mass. And you're trying to find the mass of Tigerium 131. So this one is a little bit harder. First, you're given the atomic mass, 125.125 equals, because atomic mass, that's what's on the left. My first isotope is this one. It has a mass of 124.999. And again, I don't multiply it by 94.14. I need to multiply by the decimal. So you would divide that 94.14% by 100. When you do, it's 9414. Okay, plus the next one, Tigerium 126, has that mass, 126.001 times 4.52% abundant. You divide that by 100, you get 0.0452. And then there's a third isotope. And it wants to know the mass of that third isotope, because it's saying what's the mass of Tigerium 131. So just like in math class, when you don't know something, we're going to call it X times, well, what's its percentage going to be? What do we know about percents? Because it doesn't say the percent. However, you should know all percents have to add up to equal 100. So 100 minus 94.14% was one isotope, minus 4.52% was the second isotope. That'll leave us with the percent of the third isotope, because I have to add up to 100. Again, it's percent. Percents add up to 100, which means the third isotope is 1.34% abundant. And so for that right here, 1.34% is 0.0134. Now this problem is just algebra. We're We're not going to do anything with the left side. We're going to leave that. I'm going to multiply this, and I'm going to multiply this. So 124.999 times 0.9414. Your calculator is going to give you a bunch of decimals. I suggest you write to at least 3 decimal places, because the less you round, the more right your answer will be. Multiply those. 126.001 times 0.0452, and you get 5.695 plus x times that number. You'd probably in math, you would see it written like this, 0134x. We're trying to solve for x. Before you can solve for x, you need to isolate it. Well, before I can isolate it, nothing else has x in it, so we should add those two together first. So again, I haven't touched the left side yet. Add those two. 117.674 plus 5.695 equals 123.369 plus 0.0134x. Again, I'm trying to get x by itself. This 123 is being added to that, so we want to subtract it on both sides to get rid of it. Okay, now I have 1.756 equals 0.0134x. To get x alone, we need to divide both sides by this. And that will tell me the mass of Tigerium 131. And when I get it, it is 131.045 AMU. So I hope this video helped you not only calculate atomic mass, but do more challenging problems like this one, where you're missing the mass of an isotope. How do you solve for it? Where a lot of students mess up is they don't show all of their work and they mess up with the algebra. You can do algebra 1. You can solve for x. The more work you write, like I wrote here, the less likely you are to make mistakes. I hope this helped.